Hey everyone, myself Robin Khurana. Today we will discuss some of the questions of graph data structures and algorithms. Uh, and one of the guy demanded me to solve the problem world ladder. Let's start with that problem only. Let's start with the difficult version of it. Uh, so if so, let's say if I solve this, so that then it will be your homework to solve the easiest part of this algorithm. Fine. So let's take this problem now. Now the problem is the easiest part. Now the problem is we have been given two words, start and end, and a dictionary. Find the shortest transformation sequence from start to end such that only one letter can be changed at a time and each intermediate word must exist in a dictionary. Okay, and if there are multiple such sequence of shortest length, return all of them. Refer to the examples for more detail. Okay, the question is we have been given two words. Let's say it as source and destination, and we need to reach from source to destination. And what we can do, we can just modify a word in a source, and we need to check whether that given word, whether the modified word, it exists in the dictionary or not. If it exists in the dictionary, then we will repeat this procedure again and again. Ultimately, we will reach to our destination. So we need to do it in the shortest possible way, and we need to print out all the possible sequence that is possible. Fine. And we have been given a constraints that all words must have same length and all words contain only lowercase alphabetical characters. Nice. So these are the constraints that we have been given. And what is the input format? It's given that the first argument of the that is start and end, and we have been given a dictionary as well. And we need to return all the possible transformational sequence. Fine. Okay, now let's think of an example. We have been given a start as hit and end as coke. We need to check what are the possible sequences such that I can reach from hit to coke. Okay, now let's try to analyze the problem. In this problem, we have been given start as hit and end as coke. We have been given start as hit and end as coke. Okay, as we have been given a constraint that in the dictionary we have all the words of same length and that will be equal to our start or end. So we have been given a dictionary, and in the dictionary we have word quote, and we have word dot, as well as we have word dog, and we have word load, and we have word load. Okay, so let's try to analyze. Let's first try to think what we can do to solve this problem. Okay, we have been given a first word hit. So if I want to make transformation as per the constraints, what I can do, I can only modify one word of that particular sequence of that particular word. So what I can do, either I can modify h, or either I can modify I, or either I can modify t. Now one thing that what I can do, if okay, and how many possible ways such that I can modify h? How many possible ways I can modify h? Anyone? Okay. The thing is, I can modify h to a, b, c, d, because I have also been given a constraint that each of the word is kind of a lowercase alphabetical character. So that means we know that there are only 26 lowercase alphabetical characters. So if I want to modify h, there will be only 26 possible cases. So which will be A, B, C, D up to Z. And likewise, I need to do it for I, and likewise, I need to do it for T. But at one time, I can only modify one word of it. And the thing is, if I modify it, let's say I have hit and I just modify H to A. So will this transformation is valid? It won't be. Why? Because I need to also be sure that this particular word must also lie in dictionary. Okay, these are the things that is being given to me in the question itself. Okay, so now let's try to think. Let's try to build the algorithm to solve this thing. Now, one thing that is coming to my mind, that one thing that what we can do to solve this question is, let's say we have been given, hey, now I just iterate over all the possible cases that I can think of, and for each case, what I can check whether the given modification exists in the dictionary or not. If it exists in the dictionary, I will just create a path. Let's just start create a path from hit where I can go to. In one transformation, can I go to hot? Yes, I can, because in one transformation I can modify I and it turns out into O, and the thing is H and T, which remains same. So there is only one modification and that is allowed in one transformation. So I am good with that. So what is the other thing that has been given to me? Okay, the other word in the dictionary is dot. Can I change hit to dot? Can I? No, because the thing is in dot we have been given there are two changes, two modifications, but in one transformation I can change only one word. So that is not possible. Similarly, dog is not possible. And likewise, lot is also not possible. And similarly, log is also not possible. So there is only one transformation for this, which is hot. Now from hot, where I can go? I can go to dot. Yeah, for sure I can go to dot. Okay, may I go any other place from dot? May I go any other place from hot? I can't go at do. I can't go at. Okay, I can go at lot as well. Nice, but I can't go at low. Okay, so now from load and dot, and from dot, where I can go? From dot, I can go at do, and any other place I can go. I can go at load again as well, and from load, I can go at log. Nice, and from dog I can reach to co. And likewise from load as well I can reach to log, and from log I can reach to co. But I need, there is also been given to me that I just need to concerned about all the transformations which are of smaller length, all the shortest length. So what I figured out that the answer for this will be this possible sequence as well as this possible sequence, because this is also a possible sequence, but this has a greater length, and I need to return the sequence of shorter length. So these are the two possible sequence that I just reached, and as we can see that the answer is hit hot dot dog coke and hit hot lot log coke. And so the thing is, now the thing is we analyze the problem and now we somehow trying to build a solution and somehow we reach somewhere. So the thing is, now if I at some point, let's say this is my string, the eventually what will happen, I will end up with some sort of a graph like structure, which will be something like I will end at some place like this, something like this, and it will be something like up here will be something like this, and in the end I know that as I am concerned about shortest path only, so the number of levels from which I am coming to end, it will be fixed. It is fixed. That is kind of the shortest. That is fine. The number of levels basically the shortest length of transformations. That I can surely say that. Okay, if that is the case, now what I can think to solve this question? Any questions here? Yeah, somebody Adil just told me that yeah, we can apply the BFS approach. Why we can apply the BFS approach here? Basically, we need to concern about levels and we need to figure out the shortest path. And the thing is, when we are solving the problems of shortest path, it's easy to use BFS technique. Why? Because we need to reach to some destination, and what we are doing in the BFS, we are just moving step by step. In what step? uh, which of the possible area that I can cover, and in the next step, which is the possible area that I can cover. So the thing is, as I explored in the BFS, all the possible cases that is being explored in one step. So in that way, when we are solving the problems for shortest path, it's always ideal to use BFS. So yeah, good. That is a good observation. So what we can do, we can apply some sort of BFS technique here. But the point is, let's say I applied BFS, and from here I reached here. But then what? The question is, I need to print all the possible sequences. And if I need to print all the possible sequences, and I am at here and I reached here, the thing is, what I can do, I need to basically, while doing BFS, what I need to make sure, I need to track some information that I'm thinking right now. If I track some information in such a way that basically that will help me to explore all the possibilities. The thing is, in the end, I will just end up here. When I end up here, what I can do, okay, I can build some sort of graph that will eventually be something like this. If I am able to build that sort of graph, then I'm done. What I need to do, the question then becomes really simple. If I'm able to build that sort of graph, then what I need to do from here to here or here to here, what I need to do, I need to just figure out all the possible paths. All the possible paths. Because eventually all the paths will make me here. If this is the graph, then this is basically kind of, I can explore all the paths, which is by the basic common programming paradigm through backtracking. If I use the backtracking approach, then I can easily explore all the paths. So the point is, now the question is how I'm able to build this sort of structure. This is the concern. If I need to build this sort of structure, okay, one thing somebody just explained me, we can use BFS. But how? If I'm using BFS, let's say I explored this, and I explored this, as well as I explored this. And if I mark something as visited, so if this point is reached from here, I need to also be make sure that if this point reaches from here, so this path I need to make in consideration. So one thing is coming to my mind, what I can do for each particular node, that I can just say it as node because I just turned it down into a graph. So what I can do, I can just store all other nodes from which it comes as its parent. Then it becomes some sort of simple. And if I just track this sort of information, then what I can do, let's say I am here, and I just what I can do, I just go to all of its parents. Let's say here, 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 and I use the backtracking technique. Then I reach and I explore all the parents of this node. In this way, what I end up with all the paths possible to transform this word into this. Sounds like a good approach. Sorry. Sounds like a good approach to me. The point is, we can follow this approach. Okay, so now let's try to solve this question. Let's first try to analyze what are the things that we need to consider while solving this question. Shit. The first thing is we need some sort of queue that will help us to it's okay. And there is problem somewhere. Okay, let's say we just build a queue first that is required, and after then what else do we need? We need to store parents. We need that information as well. And what else do we need? We need to maintain a queue. We need to store parents, and what we need to maintain some sort of level information as well. So let's say Okay, sorry. Uh, okay. So we need to track some sort of level information as well. Okay. I guess these all are the three things that will help me to build that structure that I just discussed. Okay, where is okay? I don't know what's happening. Okay, it's okay. Let's try to solve it here only. Let's say we need to track level. So let's try to analyze what are the things. Give me a minute. I just stuck in some issue. Wait, give me a minute. Will you all be able to see my screen now? Okay. So what I was telling, to solve this problem, what sort of information I need? One thing I need Q if I need to maintain this sort of structure, and the other thing that I need some sort of parents information as well, because I need to build that structure and I need to track of levels as well. So I need the information of level as well. So which sort of data structure that I use so to maintain all this information? First, let me try what I need, what sort of information that I need. First of all, let me first create a hash set. Oh shit, there's some problem is happening here. Wait. Let me first create some sort of hash set because I need to find in a dictionary. So that operation will become optimized. So it will consider string and that will basically my dictionary. And let's populate it with the dictionary that is being given to me. Now, what else do I need? I need the level information and which sort of data structure that I can use. I have been given a string and I need to map it to integer. So hash map will work in this case. So that is good, and that will be kind of level information, and that is good. Now, what else do I need? I need some sort of level. I need, apart from level, I need parents information as well. So, and that is also I can use hash map for this as well. So for string, as the other thing is, I can take it as vector, and that is basically storing the parents information. Fine. Okay, that is cool. So these sort of things that I need. Okay, so I need a queue as well because I need to apply some sort of BFS thing. Let's say I created a queue. So in that queue, let's first, okay, the point is while I'm creating this big structure, what I am, if I just start from here, I will end here. And if I just start here, wait a minute. Yeah, I don't know, there's some issues happening. The point is what I basically want to tell, that if I start from some place, I end up at another place. So it's good if I start from end, so that basically I will have that information from the start as well, then I can explore the parents from the start. Then I can basically easily solve this problem. What I basically wants to say, let's say I just start from here and I end up here. Now the point is, okay, there is some issues in that. Let's try to solve it without this iPad today. Okay. The point is what I'm trying to say. Let's say I just start from something and I end at some place. Now the thing is, what can then what I need to do from end? I need to explore all the paths and then ultimately reach to the end. So in the answer, what I will have end in the starting and start in the end. But what I basically want, I need start in the starting and the transformations and then end. That's the basic transformation that I want. So the one thing that I can do, I can modify start and end so that the things will become easier. So let's first do that thing. That looks simple to me that I can do that thing. So let's say I just first did that thing. Now what I can do, I can push. What I can do, I can push my start in the queue as well, and I can update the level information for start as it is at 0th level. So that's okay. Now I need to apply my simple BFS thing, and it is something like this. I need to first take out the element from the queue, and I need to pop out that element from the queue as well. Then what I need to do, okay, then I need to modify that thing. For each word that I need to do, as I explained you how the transformation will be, it will go from all the way, and for each word I need to do this thing. Now let's say I created a new word, and the new word is equal to my actual word, and I modify the ith character of it with first A, then B, then C. That's what I'm doing. Now I need to check some things. What are the things that I need to check? The very first thing that I need to check whether that new word is present in the dictionary or not. So I can safely do it like dictionary, but find new word is now equal to new word dot n. So first thing that I need to do this. Now I am sure that this word exists in a dictionary. Now I need to check whether that word already occurred or not. So I have that information. I am just tracking this information through levels. How much? What are the nodes that I just found, and what are the nodes that I just found in this particular level or at any level? So what I can do to do that, but I can just find a new word. Okay, there can be multiple cases. If that word I haven't encountered yet, that means this is the first time that I'm encountering this word. So that is good. So then I need to push that word because I'm applying BFS, and this node is, you can say, it's not visited yet. So I need to visit that node. So I need to push that new word into my queue. So now as I push that word into the queue, now the other thing that I need to do apart from that, I need to mark the parents as I already explained to you. So the parent for this new word will be equal to the word itself, because I am just coming to that new word from word. Oh, sorry. Yeah. So, oh, sorry. It's not. I just keep it as a vector. So it's good to do this way. So I just keep the parent's information as well. Else, if other than that, as I already explained, that there might be a possibility that I just occur to that node from some other node as well. But the thing is, I just take that take that particular node valid only when when that particular node is just one level away from that node. Otherwise, because only then this is also contributing to the shortest path. Otherwise, it won't be contributing to the shortest path. So then what I need to check. Okay, basically the level of new word should be equal to level of word plus one. That makes sense because I already encountered that new word. In that case, I need to just add I need to push the parent only. Fine. Now, okay, the point is if somehow my word comes to the end, so that means I already explored that particular node in which I am interested. So there is no need to explore further. So I can just break out here, and that's a good thing that I can do. Okay. So if I do in that way, I just build that structure which I explained to you. What Goel, I just didn't get what you are saying. Which thing I just erased? Okay, okay. Oh shit. Yeah, I need to maintain. Okay, sorry. Fine. Okay, now the point is now I maintained that big structure that I was interested in. Now what I need to do, I need to explore all the paths. So I need to apply some sort of backtracking technique here. So how I can apply the backtracking technique? Let's say I need some sort of answer information. Let's say I just keep it as here. Now let's say I just track my kind of the particular part here, that current part, that should I say. Now explore, I need to explore all the possibilities. So I just make a function explore, which will help me to explore every possible path. And that will basically take my start, which is actually the end, because what I just, okay, what I can do before this, I can do one thing. I can just check one thing that whether there is a possibility to figure out and or not by the transformations. So if there is a possibility that my level thing must be populated, if I just reach that particular node, so I can just check if level dot find and is equal to level dot end. That means I haven't figured out that any transformation that will end up into end. So I can safely return empty vector here. So let's say I just declared it in a way, something like this. So I can return answer like that. Now let's say now I need to explore. Let's say this is my end, and I need to reach to start. Okay, let's first try to think. Let's try to make a function, and what that function should return. I don't want anything from that answer because I will populate every answer in that particular answer vector. So I need to pass that answer vector as well, and I need to pass what is my current path, the which I am exploring now. So let's say I just say it as current, and other than that, I need to know the parents information as well. So these are the things that is required, I guess. So let's create a function explore. And I just, as I told you, that in this function, I need start, I need end, I need answer as well. It will be something like this. I need my current, as well as the parents. This parent basically it is string and vector of int. Fine. Now let's try to solve this function. Shit. What happened? It's not saved, yeah. Shit. Need to write everything again. Okay, just bear with me for today. Let me quickly write everything again. What I did, actually, I made a explore function. I check that condition. I make an answer vector. And other than that, made answer vector and current as well. And then I am checking. I'm finding the, oh sorry, and equal to that. And I just need to return answer. There is no point. Otherwise, this thing. Let's write it as well. Should be also string because string and my answer. Fine. Now what sort of logic should come here? Okay, what sort of logic should come here? The first thing that will come here is if I end up from particular node to the other node, the basically from start to the end. That means I have explored one path, so I need to push that particular path into my answer vector, and I can return from here because I need not to explore any further. Otherwise, what I need to do from any particular state, okay, uh, let's say I am at given start. From any particular start, I need to explore all its parents and I need to move to its parents. So for int, let's say I just iterate over all the parents of start, and what I can do first, I can push that particular parent into my path, So what I can do for that, as it is a vector, so I can safely push that particular node, and that will be uh, I. Now what I can do now, I can explore further, and now my kind of start will be this particular node and will remain same. Current, sorry, this bit smaller, and my answer, that is the thing that I need. After exploring, I need to backtrack so I can pop that particular element. Yeah, if I do in that way, in the end, I just need to return answer. Okay, let's first try to analyze whether we are doing in a good way or not. Is there anything that we missed? So first we created a dictionary, nice, and that dictionary basically the words that we have been given, and then we created a vector. Sorry, that we created a vector of for parents. Sorry, hash map for parents. Then we created a queue. Then we created a one more hash map for level information, and then we swap it. As we know why we are doing this. Now we are pushing in the queue first start, and we are keeping the level of start as 0. Okay, we are not updating the level. So what we can do, we can update the level of new word. Basically, it will be equal to word plus 1. Nice. That thing we should do. Now we are just popping out the word, and we are just checking if we end up into the end state. We need to just break out from this. Otherwise, we are iterating, and we are just modifying each and every word of that particular, each and every character of that particular word with all the modifications possible. Okay, I'm just doing it in a brute force way. Now let's say this is my new word, and I'm just modified it, and now I'm checking whether that new word is existing in the dictionary or not. If this new word is I found it in the dictionary, then okay, then only I need to bother about any case. Otherwise, I don't need to bother about anything. If I found out that thing, then I need to check whether in the level information I have that in word or not. If I don't have any word, that means that word is not visited yet. I need to make it visited. As well, I need to keep track of parents information as well, and I need to push that into my queue. Fine. Otherwise, what I need to do, if that word is just one level away from this, so I need to consider that particular route as well. So I can do something like this. That is fine. So now what I am doing, I am just declaring my answer, and I'm doing the backtracking technique. If I haven't found that, I need and return the empty answer. And now what I can do, okay, let's keep it as current path, and I'm exploring all the possible paths with the information that is being given to me. Okay, and now what I'm doing, if I am found something start as end, that means I reached at the end. I need to uh, basically push the current. Nice. And other than that, sorry, it's current. Now I am pushing that particular information. I missed out something. Am I missing anything? Now it looks fine to me. Let's test. Oh, okay, let's see. Uh, in function explore, okay. Uh, one thing he's telling that what the way we did is wrong. We need to we have a current here. Yeah, we have a current. Oh, sorry. Oh, sorry. I did it in a wrong way. I need to pass the parent as well. I need to pass the parent information as well. And basically that is vector string string. Yeah, that is the error here, I guess. Other than that, yeah, that is cool. Uh, it's cool. Okay, also interested. Uh, I'll be missing anything. Start and current. We are just pushing. Mm, into our answer, we are pushing current, and other than that, what we are doing, uh, we are pushing the ith element for the start. That's okay. That shouldn't be the issue here. And I'm exploring. Okay, that's another issue. And answer. Wait. Oh, it shouldn't be the issue. I don't know why it is happening. Hmm, no matching coal to. Okay. Oh, wait, yeah. Uh, Wait, let me think what is wrong here and have we missed anything? We need to push the parent and with this thing. He said I'm doing something wrong here and I didn't get that thing. What I'm doing wrong. Oh shit. These are the things. Okay. Yeah. And I'm checking whether I'm created a map. So now it won't be an issue. Sorry. So now again there is an error. Wait. Oh, it's kind of map. Sorry, yeah. Today I don't know what's happening. I'm doing some really silly mistakes. It's kind of a map, and other than that, current is fine and everything is fine. That's again test. So bear with me today. Again, okay. Now he's telling. Oh shit, doing some really silly mistakes. Okay, what's the error here now? Uh, if we find a word in a dictionary, uh, and Okay, let's keep it set. I don't know why it's happening. Hmm. Dictionary.find new word is not equal to new word dot and. Okay, new word is equal to new word. That is one more issue. Is it equal to if I find a word in a dictionary and it is not equal to. Oh, sorry. You know, I'm doing so many silly mistakes. Shit. No. Okay. I haven't explored all the parts. Why? If say I'm exploring pushback, I am doing backtracking for sure. Okay. Then I need to return. Okay. I need to explore that particular thing. Uh, it is correct. And what I need to do, yeah, I'm exploring everything. What's the issue? I am pushing that word as well into my parents, as well as I'm pushing that word as well. So where I did mistake. Wait, yeah. No, the spelling is correct. Am I missed any case? I am just checking whether that particular it is not fine. Then I'm just pushing into the queue. I am for this new word. Okay, what I'm doing from particularly from start, I just uh, making this new word a word as a parent. Yeah, that thing I'm doing in a good way. Okay, now let's try to debug it. Okay, let's try to debug. There is the issue. So now let's try to check for each particular word what is the parent kind of array. You know, let's we have been given a okay. Let's first try for this itself. This one. There's only one line in the input. The dictionary first integer is the size of the array and the get elements in the array. Uh, let's say we have been given word 4 and in the dictionary and we have been given words as sorry Paste it. Second last and the last thing are taken as start and end respectively. Okay. Code. Okay. Let's try to test. Oh, sorry. I don't know what I'm doing. It is standing now. What's wrong, yeah? Oh shit! Oh shit! One thing I missed. I need to push something into the current first, because what I'm doing, I'm pushing the parent. So what about the initial thing? So I should push that thing as well. Yeah. So that is, I guess, that's why there is nothing comes in it. Yeah, that is the mistake. Shit. Fine. Finally, we solved it. But yeah, we messed up a lot in this question. The idea is, let's now try to analyze the complexity part of it. The point is, the way we are solving, we are maintaining a queue, and the complexity for maintaining a queue, it's kind of the number of words it can have, and I am visiting each word only once because I am pushing a word only once because I am just checking the visiting case here. So the thing is, every word will be pushed only one at a time. So it will be around complex. That part will come as a complexity of number of words in the dictionary. And other than that, what I'm doing, I'm using the backtracking technique. And in that backtracking technique, I am exploring every possible path for a particular node. So the point is, now that may end up in a n factorial thing. So the overall complexity for this particular problem can go up to n factorial. So this is about this question. We have already taken so much time for this problem. Okay, now let's discuss one more problem today. Okay, let's take one more difficult problem. Let's say this one. Sorry for this thing. Okay, now what we have been given a 2D board and a word. We need to find if that word exists in the grid or not. Okay, the word can be constructed from ladders of sequentially adjacent cells, where adjacent cells are those horizontally and vertical neighboring. The cell itself doesn't count as an adjacent cell. The same ladder cell may be used more than once. Okay, the question is, we have been given basically a matrix, and we need to check whether we can construct a word out of this matrix or not. And the given thing is, from any position where I can go to build a word to any of its adjacent positions, that what I can do. And by just doing this thing, I just need to check whether I can construct a particular word or not. So this thing that I need to do. Okay, yeah, sure. I will summarize again. The question is, what we have been given. We have been given a kind of a matrix where the each element of the matrix representing a word. Fine. Now, what I need to do, let's say I need to construct a particular word with the help of this matrix. And I can start from any point from this matrix and I can go to its adjacent position only. And I can go to adjacent position and just what I need to do by just doing this sort of operation, I just need to check whether I can create that particular word or not. If I can create that particular word, I need to return true. Otherwise, I need to return false. This is my question, basically. So the point is, let's say the test cases that is being given to me, the first test case that is being given, A, B, C, C, E, D. So as we can see that, let's say I just start from the very first element of the matrix, and then I can go here, and then I can go here, and then I can go here, then A, B, C, and then I can go here, and then I can go here, and then I can go here. So I can create that word from the help of this particular matrix. So I can safely return one. Now for the other word, let's say I can create C from that particular word or not. So let's see where are S available to me, here and here. From here I can see that there is no E available in the adjacent. So I can't create a word C from this S, but yeah, I can create C from this S. I can go here and then I can go here. So the question is clear to us. So what we can do to solve this question? What is the basic thing that is coming to our mind? What is been given to us? We have been given a matrix and we need to check for the words. Check for the words. These are the things that we need to do. Okay. One thing that what we can do is which sort of thing that I need to apply to check that thing. One thing is coming to my mind. Okay, let's say if I don't know about the starting position. Let's say I can fix my starting position to any of the word which is equal to the first character of the given word. So I can do in that way. Will I be able to solve if I just explore from that particular path? Okay, if I apply any traversal, let's say DFS or BFS, can I able to solve this problem or not? Let's check. Let's say I need to construct a word A, B, C, C, E, D. Let's say I am at A, and what I can do, I can explore all the possible ways I can go from here. The basic DFS or BFS approach I can apply. Okay, but the point is when I just reach B, the word can be equal to ABA. If the word is equal to ABA, then the point is from A I need to go to B and then again I need to go to A. Fine. So the point is I can't maintain some sort of visit information. The point is I need to traverse up till when it is possible. But the one thing is I can do to break out from the kind of DFS or BFS. What I'm thinking is what I can do, I can store some sort of index that will help me to identify at which particular index of that particular word I am at. So with the help of that, I can achieve something. I can solve my problem. So to deal with that, I can track index for breaking. Okay. If I just manage to use all this information, I can solve this question. Okay. As I need to go from all the adjacent nodes from that particular node, one thing that I can do, I can create first the directions. This is the basic thing that you can also do while if you want to explore given directions. Okay, now this is done. Now the thing is, now let's try to solve this question. Okay, let's say I am applying DFS here. You can apply BFS as well. But the point is, one thing that you need to be sure that you can't maintain some sort of visit information because that is not required in this question. Okay, So what we can do to solve this, uh, as I know that my starting point can be any particular character of that matrix. So let's first, rather than that, what I can do, I just need to just figure out the length, which will be a dot size, and what will be the width of my matrix. It will be something like this. Now what I can do, I have my length and width. I can check the edge cases. If my length is 0, well, basically I don't have any element. So what I can do, I can return false, because I won't be able to create a word in that particular case. So I need to return 0. Otherwise, what I can do, okay, so I iterate over my lengths, and then I can check first whether the basically the particular character. Okay, one more thing. If I have been given nothing, if b dot size is 0, this is also an edge case, because in that case I'm automatically figured out that word. So I need to return 1 in that case. So you can check only then. What I can do, I can apply the DFS. So uh, now what should I pass to that function? Okay, that function should return me boolean for sure, or 1 or 0. I can keep it as int as well. Let's, for simplicity, let's keep it as boolean. Okay, let's keep it as boolean, and let's say we have a DFS, and in that DFS, what sort of things that is required? The very first thing that is required uh, is my current position. So let's say this is as xy, and the index basically. So I, j, and 1, because I already checked that, yeah, I figured out a particular answer. Okay, my answer is, let's say I initialize it with, I keep it as bool as well, and I just initialize it with uh, okay, I just initialize it with false or true. You can initialize. If I just find the answer here, I can just do answer equal to answer over DFS, and in the end I can return answer. Fine, sounds good to me. Okay, so how I can do now? What I should do now? Okay, I just need to be okay. I need to pass my string as well as that particular vector as well, because I need those information for sure. Okay, well as my string b. These are the things that I need to pass. If the particular index it's equal to, okay, b dot size, that means I figured out I don't need to go any further, and I can safely return true in that case. Otherwise, what I need to do, okay, I need to move to all the possible directions. I know, as I know, I have 4 directions. So I have my x updated to like this, and I have my y updated to something like this. Now I need to check whether that particular xy lies in the matrix or not. So I need to check if these xy are valid, as well as my particular, the next element, the element at x and y, it should be equal to didx. If this is the case, only then I need to proceed, otherwise I don't need to proceed. So I can move my DFS to, for this as well, I can initialize my answer to false. I can do the similar thing as I was doing before. It will be equal to answer, answer, so write simply or as well. Sorry, this is operator. Answer x basically y, a, and then b. And I then need to return answer. So I need to maintain that valid function as well. I need to pass length as well as width for these as well. And copy this, no issues. So a valid should be also a boolean. Now the thing is, now I have my coordinates and I have my length as well as width with me. So I need to return true only when my x is greater than 0 and is x is less than length and y is greater than 0 and y is less than width. If that is the case, in that case I need to return true. And now I'm just end up here, I need to return true. That's been given to me. Fine. I've been given length, width. These are the things that is being given to me. If we have length as 0, then I need to return 0. If we have been given the size as 0, then I need to return 1. Fine. Looks like a good thing to me. Okay. Okay, oh, sorry. It should be A as well as B that I need to pass. And I need to pass dx plus 1 as well here. I missed that thing. Nice. Let's submit the code now. Why we are getting error? Wait. Have I missed anything? We are just tracking every possible position as a starting position, and we are checking if that is the first character. We are moving, applying the DFS. Okay, shit. Should write it as 0. Because from this as well, I need to move to all the possible directions. Yeah. It should give me guidance. Why? Let's consider. I'm applying DFS only when we have this thing. I have I j 0 ab. Now I am checking if I have that particular element at that particular index and it is equal to and it is valid. Shit. It's greater than zero, greater than equal to zero. Really wonders today. Let's check now. What is wrong? We have been given BABAC, and this is the matrix that is being given to us. And now, am I missing anything? I have been given length as well as I have been given width. I am checking if my length is 0, then I need to return 0. If the size is 0, then I need to return 1 for sure. There is nothing wrong in this thing. Now I am initializing my answer to false. That is good. Now I am iterating over all my matrix. It's not required because it's okay. We are just optimizing it. If we have that particular element in the matrix, it is equal to B0, then only I am applying. And what I am doing, and I am just taking it, this is my answer or this. If this is returning true, then this will automatically becomes true. So there is no problem in that front. Now, uh, what I am doing, if I end up exploring all the string, then I need to return true. That is good. Now what I am doing, I need to first, I just figure out the length and then I figure out the width, and which is equal to a0 dot size. That is cool. Now what I am doing, I am exploring all the directions, and with each possible direction, what I am doing, I am checking whether this is valid or not. Okay, and for the validity thing, what I am doing, uh, I am checking it should be greater than equal to length. Griso x less than n, y is greater than equal to 0, and it should be less than width. That is correct. And if I have that particular element in the matrix is equal to this thing, so what I can do, if that is the case, sorry, if let's say from that particular node I have figured out that particular element, sorry, now I just, what I just need to do, I explored the, I just figured out that node that is equal to that particular index. Let's say it is 0, let idx is 0, and that should be my starting position. Yeah, yeah, I shouldn't do in that way. Yeah. Other than that, yeah, because automatically this will lead to wrong answer only. If basically if a of xy is not equal to b idx, then in that case I can safely return false. Otherwise, only then I need to move, and as I move, this thing will automatically will be take care of. Yeah, now what I am doing, I am passing it and removing it. Now this will be fine. Okay, the thing is, what we are doing now, there is a concern of efficiency now. Why? Because what we are doing, we are just applying this DFS every time. we are just applying this DFS every time. One thing that what we can do to uh, make our algorithm efficient, one thing that is coming to my mind, if I am getting my answer as true, I can safely return one here as well, and even here I can optimize something like this. If I figure out my answer, I can return true from here only. Yeah, I don't need to explore all the possible things by doing that way. Fine, solve this problem. Uh, yeah, the point is why we are doing it in that way. The thing is basically why I was getting the wrong answer in the previous case, because what I was doing, I was checking when I was checking here that particular condition. So the point is, the thing is, I already checked it for the here. So one thing that I missed there, that all the cases won't be covered if I just add that particular case. But if I just add that case in the beginning only, then I am sure that now this particular for this particular matrix element, this is equal to that particular index. Now can safely go further. There won't be any issues. So we are already ahead of today's time. Today I made lot of mistakes. Uh, Sorry guys. Yeah, let's also analyze the time complexity for this algorithm as well. What we are doing in our case, we are applying DFS for every possible node, isn't it? For we are applying DFS for every possible node, and the point is, in that particular DFS, we may end up in a worst case, end up in all the particular kind of the matrix, but it won't be kind of a possible thing. But in the worst case, I may end up exploring all the possible elements of the matrix. So, and I am applying DFS from each element as well. So, and but the point is, I am applying DFS up till when the size of the particular element, up till when the size of the particular string doesn't end. So the complexity, overall complexity for this will be the length of the particular string as well as the size of the particular matrix. So n into m into the particular length of the string as well. So this will be the total complexity. So this is all about today's lecture, guys. Thanks.